Imagine waking up tomorrow to discover that an artificial intelligence has already organized your schedule, answered your emails, designed a new medicine, driven a taxi across a busy city, created a realistic movie scene from a single sentence, and helped a scientist solve a problem that had remained unsolved for years. Just a decade ago, that would have sounded like the plot of a blockbuster science fiction film. Today, much of it is already happening. The most surprising part isn't that artificial intelligence has become incredibly powerful. It's that millions of people interact with these technologies every day without realizing how extraordinary they truly are. The future we imagined didn't arrive with flying cars or glowing robots. It arrived quietly, hidden inside smartphones, hospitals, research laboratories, factories, and data centers. Today we'll explore 10 AI technologies that sound like science fiction, but already exist. Let's begin with something almost everyone has experienced: talking to a machine. For decades, computers could only follow rigid instructions. They couldn't understand conversation the way humans do. That changed with large language models. Imagine reading billions of books, articles, websites, and conversations, then learning the relationships between every word and idea. Instead of memorizing answers, these AI systems learn patterns in language, allowing them to predict what comes next while understanding context over entire conversations. The breakthrough came from an architecture known as the transformer, which enables AI to focus on the most relevant parts of information rather than processing every word equally. That single innovation transformed language technology. Today, AI helps students learn, assists doctors with documentation, supports programmers, translates languages in seconds, and answers complex questions. But despite their impressive abilities, these systems don't think like humans. They can still make mistakes, misunderstand context, or confidently generate incorrect information. They are remarkable prediction engines, not conscious minds. If AI can understand language, could it also understand the visual world? That question gave rise to one of the fastest growing fields in artificial intelligence: computer vision. Every second, modern AI systems analyze millions of images from cameras, satellites, medical scanners, and smartphones. They learn much like a child does. At first, every image is just a collection of colors and shapes. After seeing millions of examples, patterns begin to emerge. Edges become objects. Objects become faces, vehicles, roads, and tumors. Today, computer vision helps radiologists detect subtle signs of disease, identifies manufacturing defects invisible to the human eye, assists farmers in monitoring crop health from space, and enables security systems to recognize potential threats. Yet vision remains surprisingly difficult. Changes in lighting, weather, unusual angles, or unexpected situations can still confuse even the most advanced AI systems. Seeing the world, it turns out, is far more complex than simply looking at it. Understanding the world is only half the challenge. The next step is moving through it. Humanoid robots are now learning skills once thought impossible for machines. Inside advanced robotics laboratories, robots spend thousands of virtual hours practicing tasks before ever touching the real world. They learn through reinforcement learning, a process similar to teaching a child through trial and error. Every successful movement earns a reward. Every mistake becomes another lesson. This allows robots to improve continuously without engineers programming every motion individually. Some can sort packages, carry heavy equipment, climb stairs, and manipulate delicate objects with surprising precision. Yet walking across an uneven floor, opening an unfamiliar door, or folding a shirt remains extraordinarily difficult. The human body performs these actions effortlessly because millions of years of evolution shaped our balance, coordination, and perception. Reproducing that ability in a machine is one of engineering's greatest challenges. Once robots can move safely, they must also navigate the world. That challenge has driven the development of autonomous vehicles. Unlike human drivers, self-driving cars don't rely on a single sense. They combine cameras, radar, LiDAR, GPS, and detailed maps into one constantly updated understanding of their surroundings. AI analyzes enormous streams of data in fractions of a second, predicting where pedestrians may walk, how nearby vehicles might behave, and when unexpected hazards could appear. In carefully mapped environments, autonomous vehicles are already transporting passengers and delivering goods. But the real world is unpredictable. Heavy rain, construction zones, unusual road markings, or human behavior can create situations that remain difficult even for advanced AI. Full autonomy everywhere is still an ongoing engineering challenge, reminding us that intelligence isn't just about processing information, it's about adapting to uncertainty. Perhaps nowhere is AI creating more hope than inside hospitals and research laboratories. For generations, discovering a new medicine often required years of painstaking experimentation. Today, AI is helping scientists dramatically accelerate that process. One of the greatest breakthroughs came when AI systems learned to predict the three-dimensional structures of proteins, complex molecules that perform nearly every essential function inside living cells. Understanding these shapes allows researchers to identify how diseases develop and design potential treatments far more quickly than before. AI is also helping researchers search through enormous chemical libraries, identifying promising drug candidates that humans might never have considered. These systems are not replacing scientists. Instead, they are giving researchers a powerful new tool to explore possibilities faster than ever before. AI is no longer limited to analyzing information. It can now create it. Type a short sentence describing a sunset over an alien ocean, and within seconds, AI can generate an entirely new image. Describe a cinematic scene, and AI can produce realistic video. Provide a few seconds of speech, and it can recreate a remarkably convincing synthetic voice. These systems work by learning the statistical patterns hidden within millions of examples, gradually transforming random noise into coherent images, music, or video. The results are astonishing, but they also raise profound ethical questions. How do we distinguish authentic media from AI-generated content? How do we protect artists, actors, and creators? As these technologies become more capable, society faces challenges that are just as important as the technology itself. Artificial intelligence is also transforming the way software is built. Modern AI coding assistants can explain unfamiliar code, suggest improvements, identify bugs, and generate entire sections of software within seconds. Engineers increasingly describe AI not as a replacement, but as a collaborator. Instead of spending hours searching documentation or writing repetitive code, developers can focus on solving larger problems while AI handles routine tasks. This partnership is expanding beyond programming into engineering, architecture, finance, education, and scientific research. The future of work may not belong to humans or AI alone, but to those who learn how to combine the strengths of both. Beyond helping individuals, AI is beginning to accelerate scientific discovery itself. Researchers now use AI to search for entirely new materials that could improve batteries, design more efficient solar cells, model Earth's changing climate, analyze signals from distant galaxies, and simulate physical processes too complex for conventional computers. Rather than replacing scientific thinking, AI allows researchers to test far more possibilities than would otherwise be practical. It acts as an extraordinarily fast partner, narrowing billions of possibilities into the most promising paths for human experts to investigate. Perhaps one of the most extraordinary frontiers lies at the intersection of AI and the human brain. Brain-computer interfaces are allowing researchers to decode certain patterns of neural activity and translate them into digital commands. In early clinical studies, people with severe paralysis have used these systems to move computer cursors, type messages, and communicate using only their thoughts. AI plays a crucial role by recognizing subtle patterns within enormous amounts of neural data that would be impossible for humans to interpret manually. While this technology remains experimental and faces significant technical and medical challenges, it offers hope that millions of people with neurological conditions may one day regain abilities once thought permanently lost. Finally, we arrive at one of the newest developments in artificial intelligence, AI agents. Unlike traditional chatbots that simply answer questions, AI agents can plan, reason through multiple steps, use digital tools, search information, write reports, organize schedules, and complete increasingly complex tasks with limited human guidance. Researchers envision future AI systems acting as digital assistants for scientists, engineers, businesses, and even entire governments. Yet these systems still require careful supervision. They can misunderstand goals, make incorrect assumptions, or struggle in unfamiliar situations. Building truly reliable autonomous AI remains one of the greatest challenges in computer science. Taken together, these 10 technologies reveal something remarkable. Artificial intelligence is no longer a distant promise waiting somewhere beyond the horizon. It has already become woven into the fabric of modern civilization. Some systems help us communicate. Others help us heal diseases, discover new materials, navigate cities, build software, explore the universe, or restore lost abilities. Many of these breakthroughs would have seemed impossible only a generation ago. Every major technological revolution expanded human capability. Steam engines multiplied our strength. Electricity transformed civilization. Computers amplified our ability to calculate and communicate. Artificial intelligence may become the first technology that significantly amplifies human reasoning itself. That possibility carries extraordinary opportunities and equally significant responsibilities. The question is no longer whether AI will shape our future. It already is. The real question is how wisely humanity will choose to guide its development. If you enjoyed this journey into the world of artificial intelligence, let us know in the comments which technology amazed you the most and which breakthrough you believe will have the greatest impact on our future. Don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next exploration into the science and technologies shaping tomorrow. Thanks for watching.